Okay, so now we want to find the area of the shaded region, the shaded area. So I hope you can see it's just total area, the big circle area, minus away the unshaded area. Then you will get the shaded area, right? So what we need to find is really just area of the big circle, and then we find area of the small circle, and we subtract them. Area of small circle, that one obvious, huh? You got radius to be 3 cm, just use formula. Just use the formula, pi r squared, pi times 3 squared. We get area of the small circle. That's the easy part. The difficult part is to find out the area of the big circle. The area of the big circle, which means that we need the radius of the big circle. And let's just focus on OA here. OA. Agree, right? It's a radius of the circle. Goes from the center O all the way to a point on the circumference. Good. So now our goal is to find out OA. And I realized that OA is actually a part of this right angled triangle here. ADO, which I've already drawn over here. ADO, right angle, so let me just label. We deduce that tangent perpendicular to radius previously, 90 degrees. Okay, but this one, 65 degrees, is because of similar triangles. This triangle and that triangle are similar, so angles in the same position must have the same angle. So it's 65 degrees as well. Okay, what you need to realize next is that actually there's the OD as well as this O. I labeled here this point P. OD and OP. Okay, they are what? They are really just the radius of the small circle, right? Radius of the small circle, which we already know. They must be equal, and their length is 3 cm. Length is 3 cm. This length here, not so relevant. This one, more relevant. Why? Because, remember what was our goal? We wanted to find the radius of the big circle, right? To find the area of the big circle. So we need to find the radius, which is OA, which is this length here, which happens to be what? The hypotenuse of this right angled triangle. And we got an angle, and we got one of the lengths. I hope you can see by now that it's really just cosine of 65 degrees, which is equal to 3, the adjacent side, divided by OD. This is OD. 3 divided by OA. Okay? So we can just make OA the subject. 3 divided by cosine 65. The algebra. I'm sure you can work it out. 3 divided by cosine of 65. Make sure your calculator is in degree mode, and you will get 7.098604 cm. Okay, good. That's OA, the radius of the big circle. So now we are done. We essentially solved the question. We just need to present it formally. So area of shaded, I'll just write all in one line. It will be equal to area of the big circle minus area of the small circle. So what's the area of this big circle? It's just pi r squared, but the radius we know it's OA. We know it's, let me just, okay, I'll just zoom in. I hope you can visualize it in your head. Just big minus away small. So, 7.098604 squared minus away area of the small one, which is pi r squared, and the radius is 3. Typing in your calculator, and let's see what I get. I will get 130.0311, rounding off to 3SF 130 cm squared. Okay, maybe it should be the other way around. This is the approximation. This is exactly equal to 3SF. Exactly equal to 3SF. Okay, done.